My title is Remote Sensing Image Classification based on Salmon Supervised Learning Algorithm. Current machine learning algorithms often need more labeled training samples to get better performance, such as the deep learning approaches, sparse classification approaches, and semi-supervised learning approaches. However, the labeled samples are very difficult to get for remote sensing image data. To address these problems, in this article, a semi-supervised quantitation algorithm based on the Cartesian k-means algorithm is proposed, which named it as the semi-supervised Cartesian k-means (SSCK), and then we applied it for remote sensing image data classification. In the semi-supervised Cartesian k-means algorithm, supervised information is integrated into the quantizing algorithm by resulting a supervised construction Laplacian recognizer. Experimental comparisons with state-of-the-art algorithm over classical datasets demonstrates the invention of our proposed semi-supervised Cartesian k-means. Remote sensing image classification is to use the computer to analyze the spectral information and the spatial information of all kinds of ground objects in the remote sensing image. Select the features, divide each pixel in the image into different categories according to some rules or algorithms, and then obtain the corresponding information between the remote sensing image and the accurate ground objects so as to realize the image classification. The accurate classification of remote sensing images is based on the similarity of pixels of remote sensing images. Distance and correlation coefficients are often used to measure similarity. Common classification methods are supervised classification and unsupervised classification. Quantizing plays an important role in the ANN research work. It does the job by adopting the data representation strategy. Product quantization is an algorithm where the space is decomposed into Cartesian product of low-dimensional subspace, and each subspace is quantized separately. The distance between the carry and the base state is the summation of subdistance, which computed in all subspace. To efficiently reduce the quantization error in each subspace and improve the retrieval performance, we propose semi-supervised Cartesian k-means algorithm. In this paper, it firstly constructs a Laplacian retriever based on the labeled data. The similarity computation between two samples who share the same labels will be given a large value, while that belong to different clusters will be assigned a small value. Then add a Laplacian recognizer to superfraction loss functions to construct the semi-supervised Cartesian k-means objective function. Optimization algorithm is given to solve this problem. The classical k-means per sample component analysis (PCA) and normalized cut et al. Can be considered as a special case of optimal resolve procedure production analysis. Based on this concept, in the quantizing producer to give the semi-supervised Cartesian k-means algorithm based on input space decomposition strategy. The semi-supervised Cartesian k-means can be formulated as following. To solve this problem, we introduce the Laplacian recognizer turn into the above semi-supervised Cartesian k-means modes of and get the following formulations. We construct the similarity matrix W. We use supervised motions. Intervals will be analyzed a large weight if and have the same clustering number, and a small weight will be given if and belong to different clusters. We compare our semi-supervised Cartesian k-means with several state-of-the-art motions, product quantizing, current k-means, correlate attention network, kernel product quantizing, online product quantizing, semi-supervised extreme learning machine, organized k-means, and interval quantizing, as well as the composing quantizing. Comparing the conventional Cartesian k-means, our proposed semi-supervised Cartesian k-means has improved the performance effectively, which shows the efficiency of our semi-supervised Cartesian k-means algorithm. Comparing the conventional Cartesian k-means, our proposed semi-supervised Cartesian k-means have improved the performance efficiently, which shows the efficiency of our semi-supervised Cartesian k-means algorithm. The experimental result comparisons between SSCK and the Cartesian k-means shows the efficiency of the SSCK on the image retrieval task. Experimental results shows that SSCK perform better than its competitors on all the three experiments, or of use 32 and 128 bits code length respectively. Product quantizing have the worst performance except by using 32 bits code experiment. That's because the feature occur a great change on the bits code, and this kind of analysis is not suitable anymore. All the anagrams expect the product quantizing have adopted the rotation mixtures to adjust the demonstrability of samples to reduce the errors. Comparing with the Cartesian k-means, our proposed SSCK can eventually improve the ANN search performance on the inner array image dataset.